Now, whenever you write log a, there are some background properties which you must know that a is greater than 0 and base is not equals to 1. It's because if base is 1, you are basically asking what is the power of 1 such that I get this number. Right? Maybe so that I get 20, but any power of 1 is just equals to 1, so the answer will be undefined. That's why we just excluded 1 from the base. You might be thinking, why not the smaller number and up 0 to 1? It's because if you're asking what is the power of 0.1 such that I get 20, uh, that's kind of possible with a negative aspect. So yes, the answer of a log can be negative, but either the base or the variable are allowed for negative sign. So these must be positive, but the answer can be negative. Why in this case it must be some negative number. So I don't know, let's say negative 10 or something like that. You get 20. There are some more properties such that the log with any base to the 1 is just equal to 0. It is because you're asking what is the exponent of base such that the answer comes to 1. That only happens when the exponent is 0, right? Because anything to the power of 0 is equals to 1. So that's why. Similarly, if you have the same base and the same number, so a is just equals to 1 because a to the power of 1 is equals to a. Now, there are some more important rules, specifically the inverse rule. So if you have this a, so is a, and then you have another log. Now, the log of a and the a to the power of something, they cancel out each other, and you just left with log base x. Similarly, if you had a log where with, let's suppose a is a, and then another one, and then x, the log of a and a is equals to 1, so both of these things cancel out, and you get answer as x. So whether it's a to the log a or log a to the a, you both cancel out, and the answer is simply x. Now this rule is very important when you're simplifying the logarithms. So for example, they ask you to simplify 2, 3 log 2 to the 5. Now you cannot directly cancel 2 and log 2 because of this 3 over here. So that's why you would first take step 3 by using the power rule. It will be 5 cube. Now after making it 5 cube, now we can use the rule which says you can just cancel out 2 and log 2, and then you are left with 5 cube, which will be equals to 125. Similarly, if you had a variable instead of a number and you have to simplify them, you can use this rule. So let's take log a to the 5x. Again, the same will apply, then the answer would be simply 5x. Similarly, if you have numbers, let's say log of 100 raised to the power of 5, and the base is 10. You cannot just simply cancel them because base is 10, the number is 100, but you can use your brain and simplify the 100 to 10 square to the 5, and later on 10 to the power of 10, and then these two cancel out and the answer comes up to be that in this case. Now, sometimes there are a few word problems which are have to be solved using logarithms. For example, it says so 16 times and the double every hour. You can use logarithms for solving this question. You can, since it doubles, the rate is 2, and it reached 16 times. So the number, now you're finding the time it takes. So you're basically finding the exponent of 2, which makes it equals to 16. So you can just start by simplifying it as log 2 to the power of 4, taking 4 to the left hand side. And now since the base and the number are same, it should equal to 1. It would be 4 hours. You can also solve it in exponential form such that you double the every hour. So after the first hour, number would be twice. After the 2 hours, it would be 4. After another hour, it will double again. It would be 8. And another one more hour, it could double again. It will be 16. So as you can see, 1, 2, 3, and 4 hours are taken. Sometimes they also give you a kind of complex extractions which have to simplify. For example, log 3, 15, and times log 2, 8. In this case, you can start from writing down 15 5 times 3 because you have the base 3, and now it's also multiplied. Log 2 of 8 is simply 3, and when you simplify this one, it would be log 3 3 plus log 3 5 times 3. Uh, you know, remember putting these brackets because otherwise you can get a wrong answer. So 1 plus log 3 5 times 3. And now if you look at the options, you will have something like this: 3 plus log 3 5. Or they may even make it more complex by taking the 3 as an exponent on 5, so log 3 5 cube, and solving it as log 3 125. So look for any of these options and you will check the right one. So there's one more thing that somehow students confuse themselves up between a hypothetically log of a plus b. There is no such rule for this type of expression, and similarly no such rule for log of a minus b.